If this round doesn't end up like basically building AGI, then there won't be more money in the world left to
Yeah.
invest in AI. And
Yeah.
therefore, you just can't. Like the economy is not large enough to support an, um, you know, an increase in data center size at the
Mhm.
scale out rates that we've seen over the past few years. Once we're at the point where OpenAI is basically being entirely run by AIs as
Mhm.
opposed to humans, we're probably cooked if the ads are
Mhm.
misaligned. Yeah, I would say I am not very optimistic. I
Okay.
would say that,
Great to hear.
yeah, I would say I'm very concerned. Yeah.
Hello, everyone, and welcome to the Intelligence Horizon podcast, where we speak with experts from a variety of backgrounds within AI to better understand this enormously transformative technology. I'm one of your hosts, Owen, and I'm joined by my co host, Will. Our guest today is Thomas Larsen, a researcher at the AI Futures Project and co author of the highly influential AI 2027 paper. Thomas previously founded the Center for AI Policy and has conducted safety research at the Machine Intelligence Research Institute, as well as the Stanford Existential Risks Initiative. He has emerged as a leading voice on the intersection of AI forecasting, alignment, and policy. Welcome, Thomas. It's great to have you today.
Yeah, thanks for having me.
Okay, so to get started, we imagine that our listeners are coming in with a variety of perspectives on what artificial intelligence might be capable of in the future, and maybe some ideas about what AI will simply never be able to do. So, in the interest of understanding your worldview better, what kinds of AI systems are you most often thinking about when you're talking about AGI or artificial general intelligence? Like, what can this AGI do? Is there anything that it, in principle, like cannot do ever? Yeah.
Yeah, so I think I'm often imagining a when I think of AGI, artificial general intelligence, uh, very capable AI system that can do sort of all tasks that humans can do and more. Um, the reason I think so much about like that type of AI, which is a obviously a future type of AI that doesn't exist yet, is because if such a system would be built, it would obviously have like huge effects on the world, profoundly transformative effects on the world, and would therefore be like hugely consequential technology for how the future plays out. Um, we could go into, if you're interested, there are various like people, sort of everyone has various their own definition of exactly what AGI is. I think we often try to use like more specific terminology. Like in our AI 2027 report, we talked about like superhuman coder, for example, is a sort of more precisely operationalized milestone than AGI, um, to sort of get a little more fine grained because, yeah, there are a lot of different, I guess, there are a lot of different types of AGIs. In particular, the beyond the human range of AI capabilities, at least my view is that there's going to be like there's a huge wide spectrum of AIs that are about as good as humans at most things, and then there are also AIs that are like vastly better than humans at everything.
Yeah.
Um, and I think like recognizing that that is a big gap, and that the wildly super intelligent, much smarter than all human AIs look very different than the just barely superhuman AIs, is like sort of
Yeah.
an important conceptual point.
So, sort of like a spectrum you're defining when you're talking about AGI as a whole, or something that's better than just like the AI capabilities that we are at right now, right?
That's right. Yeah.
Okay.
So, at what point would you personally say, okay, we've sort of like crossed that line and we're at this point where it is general or it does become super?
Yeah. So one specific point I think I like to think about is the point at which an AI can fully automate a frontier AI company like OpenAI or Anthropic.
Okay.
And so what that means is basically for everything that that company does, uh, an AI is better and cheaper than a human. Does not mean that humans are useless, of course, because comparative advantage still exists. Even if the AIs can do them better, it still makes sense to have some humans involved in those tasks.
Mhm.
But it is sort of the point at which I expect progress to go to like start going much faster, and
Right.
is like a bit before I expect to see hugely massive effects on the world.
Right.
Um, so I don't know. I think that's sort of my favorite definition right now. Though, of
Okay.
course, you can debate, you can throw out other definitions, and many do.
So that sort of previews the discussion of like the intelligence explosion, where we have AIs automating AI R&D. Like I presume that's why you define that milestone as something that you're looking towards. So we'll get back to that, but maybe just to get a little bit more on the table in the way of introduction, can you like outline the best reasons, in your opinion, for believing that this sort of superhuman coder milestone is plausible within the next decade or so? Like the broad contours of the arguments. Yeah.
So sorry. So actually, I want to distinguish a little bit. The superhuman coder milestone is actually slightly before the full automation milestone.
Okay. Right.
And is slightly distinct, but it's not that important.
Yeah.
I think for both of these, like the reason to expect. So I think there's a few. I guess there's a few premises maybe that I should lay out. So one premise is, it's in principle possible to have an AI system that can do anything that a human can do. And this premise sort of follows from like physicalism, like basically this sort of premise that like there's nothing fundamentally special going on in human brains. It's, it is just physics all the way down. Yeah, there's no special juice. It's, it's all physical processes. It's normal laws of physics, and we can capture that on computers.
Yeah.
So that's premise one, and I think I'm extremely confident in premise one. Premise two is maybe that it's not that hard to build an AI system that can do everything a human can do. And to maybe make that a little bit more precise, maybe I'll say something like the process that produced humans, evolution, is something that we know how to code on computers right now if we had enough processing power. So if we had basically a big enough server to train AIs, like for example, maybe 10 to the 40 floating point operations, like a server that could do that many floating point operations in a year, I would feel very, very confident we could build like AGI or AIs that could fully automate AI R&D. Okay. So that's maybe the second premise. And then the third premise is like, in fact, I think we could do way, way, way better than evolution. And and that's sort of getting on what are the algorithms we're actually using today? What are the results we're seeing out of those algorithms? And they look pretty promising to me. So maybe that's sort of a very high level breakdown. I could get into the specifics if it's interesting, but yeah, maybe that's the high level conceptual, I think, breakdown.
I think that conceptual breakdown is very interesting. So the idea is that in principle, we could just like automate the process of evolution if we had enough computational power. And human brains were formed via this process of evolution. So, there's no reason that if we replicate it perfectly at the physical level, we wouldn't get like some sort of intelligence equivalent to human brains. I think, so like there's another category of arguments for like thinking that AGI is around the corner, which are sort of less object level and more like heuristic in the sense that they maybe refer to investment in AI, right? Like we're seeing, these experts in Silicon Valley with their entire fortunes on the line, throwing hundreds and hundreds of millions of dollars in this technology. Is that an argument that you look to? And then you also have like the leaders of labs like Sam Altman, Dario Amodei saying that AGI is right around the corner. Is that something that you think about in your calculus, or are you strictly trying to hash out like the sort of more technical arguments?
So I think that those are important sources of evidence. So those you sort of brought up two. There was first the economic impacts of AI, and there's second the like insider perspectives.
Yes.
So the economic perspective, I think that the current like wave of investment into AI is very big. One might naively think that at around the point of AGI, AIs will have sort of a similar size economy than the human economy by virtue of them being similar capabilities. So maybe one heuristic way of estimating when we get AGI is to basically take out the trend of, okay, here's the revenue that's produced by AI companies, and here's the revenue that's produced by the rest of the economy. And of course, the AI companies line is going way faster than the rest of the economy, right? The rest of the economy is increasing at like 4% GDP growth per year or whatever. And frontier AI companies are increasing at like 3x per year in terms of revenue. And so, it won't take, I think the current revenues for the frontier AI companies are something like $10 billion each per year. Um, and so it doesn't take that many, and world GDP is obviously roughly $100 trillion.
Yeah.
And so, um, doesn't, it's maybe fourth. So it's 4 orders of magnitude off. And so at the
Yeah.
naive rate, right, of doublings, uh, that's 4 orders of magnitude, and like 3x per year is about half an order of magnitude. And
Okay.
so
Yeah.
that's 8 orders or 8 years until you
Okay.
get,
Interesting. Yeah.
your AI company. Each AI company is as big as the world economy is today.
Interesting. And maybe even less, right? Like if you're thinking about like this from like the heuristics of an economic perspective, like if you think about like there's not a clear delineation, I guess, between like the revenue that the frontier models are producing, but also when you're thinking about the revenue of like non-AI frontier models and what they're producing, a lot of the times we're seeing like use cases based off of like the products that these frontier models create, right? So there is a sort of like notion there where there's like a muddleness in like the non-AI companies that are also like relying on these frontier labs to sort of produce and like produce revenue. It's interesting.
Yeah, totally. So I think my understanding of the thing you said is that basically the impact of AI on the economy is much larger than is what just captured by the
But
revenue.
yeah, exactly.
There's
Exactly.
also consumer surplus basically
Yeah,
generated
yeah,
by the
yeah,
AIs.
yeah.
And I think that's right. And so I think what I said was in fact an underestimate in that regard.
Interesting.
Though it's also an overestimate in some ways. In particular, I expect the revenue trends to slow down probably.
Okay. Yeah. So we have the economic argument, sort of the technical argument, um, and I guess you were going to say something about maybe the credence you give to someone like Sam Altman's
Yeah.
claims.
I don't think the lab leaders have very good epistemics
Right.
for how fast AI progress will be, and I think they're
Mm-hmm.
pretty bad and pretty misleading in their public communications about it. So I tend to not give them a lot of weight. I think I give more weight to like particular insiders at labs who like engineers who I feel have like been more consistent, have had more consistently high quality epistemics, and have a less like huge like political incentive to mislead people, which I
Right.
think the lab CEOs have.
Yeah.
So yeah, basically, I think the engineers are a much better source of evidence than the CEOs, and I would not recommend listening to the CEOs if you want to clearly think about what's going on in AI.
So I guess like I guess on that point then, like for someone who's like looking, I guess from the outside in and like seeing all this hype that's being created by like Sam Altman, Dara Amade, and all these people, like how would you like recommend sort of like sifting through that information and seeing like what are reliable sources and what aren't towards like gaining a better understanding of what's going on in the progress in AI?
Yeah, so I mean, I guess not to toot my own horn, but I think a large part of what we're trying to do with the AI Futures Project is to try to produce uh, documents that will be like useful for the general public to read and orient to the situation uh, in a way that is hopefully like helpful to the public discourse and
Yeah.
for the public to sort of think more clearly about this issue.
Yeah.
So I don't know. I think we produce reasonably good work that succeeds at this goal. So I guess I recommend our own work.
Awesome.
There's a bunch of other places that produce really good work that I think are like much higher quality than like what gets most widely read. So for example, Epoch AI, I think
Mm-hmm.
is pretty widely cited in the AI
Mm-hmm.
policy space, but not really by the general public and media. And I think they do very good work on sort of the technical, a lot of the technical forecasting trends, things like what I was just saying, like the revenue growth per year, the like
Right. Yeah.
amount of, here's how much bigger the servers are getting every year. Here's how much bigger, the training runs are getting every year, et cetera. Um, I think they have the best data in the world for that kind of thing.
So
Do you want to ask the next one?
I guess many people are sort of skeptical now, looking on the other side, that AI will ever reach this point, let alone within like the next few years or the next few decades. And I'm sure like part of your job is constantly dealing with these people and talking about why this is like an imminent case that we need to talk about. And I think one thing that we often hear, at least amongst our peers, is that LMs aren't that they're like really impressive at doing these mundane sort of like coding tasks. But when we think about this like general intelligence, they don't really feel like it's necessarily there. They still hallucinate. They still trip up sometimes on things like basic logic puzzles. So I guess like my question is, do you sort of find this picture somewhat compelling? If not, can you sort of steelman or discuss a case for AGI not coming within the decade that you oftentimes find most compelling?
Yeah, totally. So, okay. So I'll start with the like standard critics. I
Yeah.
find the standard critics arguments to be extremely unpersuasive. Uh, I think that, I mean, people complain about reliability, people complain about hallucinations. I don't know, like I hallucinate all the time. Like
Mhm.
I often make mistakes. I often make basic logic errors, as
Right.
do I think most humans.
Right.
Um, I think like I have a math degree. I was pretty good at math in my undergrad. Um, and I think, GPT-5 is like better than me at math in most
Yeah.
ways, in the sense that if you gave it an exam from my, undergrad,
Yeah.
it would just do better than me on every single exam, basically.
Yeah. Yeah. Yeah.
Um, and I don't know, you could say that's not really intelligent. I feel like this is basically just constant, goalpost shifting.
Mm.
um and I don't know, I don't really think the like is it real intelligence is a like meaningful construct, really. Like
Mhm. Mhm.
there's only like what can it do and what can it not do.
Yeah.
And I agree that there are lots of things that the models can't do that we can do. In particular, I think the models are worse at long horizon tasks than we are. So they're
Mhm.
not, you cannot give a model right now like
Yeah.
uh, an open-ended like week-long or month-long task, a
Yeah.
thing that would take me a week or a month to do, and
Yeah.
have it come back and do those tasks,
Yeah.
and like do that as tasks successfully. And
Yeah.
that's a key limitation right now.
Yeah.
um yeah, so I don't know, so I'm like, the naive version that I think often gets repeated is quite uncompelling to me. I do
Mhm.
think that there is a version of the argument for the bear case for AGI that is compelling to me.
Yeah.
um what that argument is something like, right now the trends are increasing really quickly, right? Like the revenue trends, the compute trends, those have to slow down pretty soon, like probably by the end of the decade.
Right.
And if those slow down, then we'll probably be in an AI winter, right? So if we get to AI 2030 with, if we get to 2030 without building AGI or like crazy AIs,
Mhm.
uh, then the rate of progress of all of the inputs, like investment and compute and talent, will start increasing at a much, much slower rate than they
Mhm.
have in the last few years.
Mhm.
Um, so being a little more concrete, right? Like I talked about the revenue trends. Uh, we can also talk about the compute trends. Um, if so, sort of there's this current round of scaling where they're trying to invest, hundreds of billions or maybe even trillions
Right.
into data centers.
Yeah.
Um, if this round doesn't end up like basically building AGI, then there won't be more money in the world left to
Yeah.
invest in AI. And
Yeah.
therefore, you just can't, like, the economy is not large enough to support you know, an increase in data center size at the
Mhm.
scale out rates that we've seen over the past few years.
Right. Right.
So like once we were spending $1 trillion on a data center, it's just way, way, way harder to triple in size than it
Mhm.
is, when you're only spending $1 million or $1 billion on a data center.
Yeah.
So,
Yeah.
so there's sort of like a bimodal probability distribution or something. So like if AGI doesn't come within the next, I don't know, like when are these data centers coming online? The next 5 years.
Yeah.
If it
Yeah.
doesn't
What?
come then like there's a long tail of when AGI will come online. That's what you're saying?
That's right in vibes. I'll be a
Okay.
nitpick. I'm sorry.
Yeah.
The bimodal I think is technically somewhat wrong because I don't think there's actually another peak,
Oh,
right?
there's
Like
other
a
people.
bimodal
Okay.
is like two
Sure.
bumps.
Right. Right.
I
Right.
think there's not actually like a second bump. There's
Yeah.
just a long tail.
Makes sense.
But yeah, I think that is my view, that we should, take seriously the possibility of HI in the next 5 years, and then if it doesn't happen in the next 5 years, it could be a while.
Interesting. So on like a time from like a timeline perspective, do you project that sort of like usage of like those trillions of dollars in investment to have to sort of outcome into something by 2030? Or is this sort of like a little bit more like opining on when that funding is used up?
So I currently think we don't know and that no one knows. My current views is like, I don't know, 50-50.
Yeah.
Maybe we'll get AGI by 2030, maybe we won't. It's hard to
Yeah.
tell.
Yeah.
It's very hard. It's, obviously very hard to predict, technological progress and like
Yeah.
new discoveries.
Yeah.
And we'll scale up, we'll add a lot of GPUs to the training piles.
Yeah.
Uh, maybe that'll lead somewhere. There are like some reason to think it would, like, uh, you know, it is getting a lot bigger. It's going to get maybe 2 orders of magnitude bigger, the
Yeah.
training compute by the end of the decade.
Yeah.
And, the current models, they seem pretty capable. The trends in things like here's how long of tasks the AIs can do. Here's how difficult the tasks AIs can do. Seem like they're increasing pretty quickly. But there are also reasons to think that, it wouldn't happen. Um, like the models have not been that useful at like downstream real world tasks. They still
Okay.
aren't, generalizing far off their training distribution to like,
Right.
solve new scientific problems, though they're, starting to help. Right.
Yeah.
There was recent, we could talk about the recent things that it's helped with. So I think it's really uncertain. I think we don't know, and I think people who are confident sort of. I don't have a lot of sympathy for people who are really confident one way or the other.
Okay. Okay, so let's jump into AI 2027 a bit. For our listeners who haven't read the piece, AI 2027 is a forecast of the next few years of AI progress, all the way up to ASI or artificial superintelligence. It's specifically zoomed in on this, next 5 years timeline that Thomas is just describing, when we're pouring all of this compute and research talent into AI and seeing what comes out of it. And it was written by Thomas and the co-authors at the AI Futures Project, including Daniel Cocotello, a former OpenAI employee. The piece gained widespread influence in the AI community and beyond. There have been indications that important people in the USG have read it, including JD Vance. So for you, Thomas, for our listeners who haven't yet had exposure to AI 2027, can you give us a brief overview of the piece, like what it is, and what are like the main arguments, main points in the timeline?
Yeah. So AI 2027 is basically a scenario that outlines sort of our best guess for what the next few years of AI progress looks like, conditional on the fast timeline to AGI.
Right.
And of course, like I said previously, we're not confident that this is the exact timeline at all.
Yeah.
Right. This is just one timeline that might be true for all we know, and is also on the faster end. So the summary of the scenario is basically AI progress keeps going really, really quickly. We start to see by 2026 AIs that are pretty good at coding, so they can automate most coding jobs in particular within the AI labs. And so AI labs like OpenAI, Anthropic, and Google basically reallocate their humans from coding tasks to more like research scientist, research ideation tasks. And this basically increases productivity within the AI labs quite a bit, because the AIs are basically doing all of the coding, and the humans can just do the like thinking and processing of the research results. And so that starts to speed up progress. And then that leads to, by early 2027, AIs that can not just do the coding parts of research, but also the research ideation parts. And by mid 2027, we sort of see these like full automation AIs, like these AIs that can automate the whole AI lab. And this sort of just keeps on snowballing and snowballing into more and more capable AI systems. And at the same time as this sort of capability storyline, there's also this alignment storyline, which is what are the goals and values that this AI system actually has. And in mid 2027, the researchers at the leading AI lab in our scenario find substantial evidence that this AI is in fact not aligned to the human producers, and instead has developed its own goals. And the evidence they get for this is things like the AI is sandbagging on research, is deliberately underperforming on research that would be helpful for the humans to sort of better understand what was going on inside the AI's head. And so they get this sort of evidence, and then they're faced with this decision point where a scenario branches. And in one branch, the leading AI company decides, look, we're in this race with China. We're also in this race with these, domestic competitors. Yeah, this is a warning sign. We can patch it quickly and, continue on ahead. And in that scenario, that's sort of the bad ending, where we see the AI, continue to be misaligned. The patches didn't work, and we get all the way up to AIs that are way, way, way smarter than the smartest human. And those AIs end up taking over, and we have sort of a concrete story for how that takeover ends up happening. In the other branch, it's more optimistic. It's the branch where the humans are able to basically pause for a few months, reset to an earlier version of the AI model, um, do a bunch of science very quickly, and desperately in the nick of time, figure out how to align AI systems to their human creators, and then in that world, it still wasn't fully great because the AIs ended up aligned to, the tiny group of government officials and lab
Yeah.
executives who were in charge of the AI project at this point,
Right. Yeah.
and conferred onto them sort of a lasting, durable power
Right. Yeah.
enforced by the AIs.
Yeah.
And so, yeah, that's sort of the summary of the scenarios. In one branch, we get the AI takeover. In one branch, we get the sort of human concentration of power.
Yeah.
And yeah, that's AI 2027.
Okay, amazing.
Yeah, interesting. Yeah. So it seems like from the way you're phrasing it, Thomas, is that like, when people usually characterize, I guess, like the speed up versus a slowdown, one being like good versus bad, it's not necessarily as like black or white as like good or bad, right? There seems to be like different like major issues that you face on other sides, whether that be like with AI misalignment or whether that be with like the concentration of power, right? So I think like it's pretty interesting there how it doesn't necessarily seem that one is necessarily better than the other.
Yeah, I mean, I guess I would say honestly that I would, if I had to choose, I might take my chances with the concentration of power over the
Okay.
misalignment.
Is it close?
But I mean, I think both are very scary. And I also think what you said was very right, that it's not a choice, that there are, in fact, things we can do to um, sort of reduce both of these risks
Right.
substantially. And
Right.
part of what we wanted to do with AI 2027 was sort of get more people to understand the dynamics here so that we would hopefully see a good societal response to AGI, which would lead to both of these risks going down by a lot.
Oh, so sort of like the theory of change or the theory of impact for writing this was that if more people are alert to this, both the concentration of power risk and the misalignment risk are reduced in the sense that, like right now, the only people that are really thinking about this are the people in Silicon Valley building these things, and they have financial incentives to like, concentrate the power and downplay the misalignment risk. So sort of the idea is that if broader society is thinking about this more, then yeah, these risks are reduced. I guess maybe like the one concern would be that if the people who are in power are reading this and they're like, oh my gosh, like this is possible, then they might be like more incentivized to want to go out there and take the power for themselves. So like, yeah, have you thought about this reception, these opposing?
I think there is just a trade-off here where, in some sense, what we're doing, at least if we've done our job well, is helping society sort of think more clearly about AI. And that does cut both ways. Like there are, in fact, bad people out there who will use better public epistemics, better public scenarios for like what's going on to, be better at scheming for power themselves and do bad things, and race for AGI and whatnot. We're worried that, lab leadership will read our scenario and then be better at, modeling how exactly to do a power grab.
Right.
In some sense, we're taking a bet on the government and society more broadly that the increase that they'll do more good things with this knowledge than particular bad people will do with this knowledge. And my view is that most people are good, and that on net, hopefully this is positive. But obviously, I agree it's a concern.
Yeah. So since releasing it, based off of these like overarching goals that we've just covered, have you like what is your sort of analysis on the situation right now in terms of the achievement of this goal of making this more accessible and more discussed throughout the communities? Of course, as we talked about,
Like it's gone well. I don't know. Like you guys seem to have read it. Various people in the government seem to have read it.
And can you talk a little bit about that traction that you're seeing, like in the government or like in the broader community?
Yeah, I mean, so I guess my sense is that there was a real hunger for sort of concrete, well thought out scenarios for how AI might play out. I think oftentimes before we'd released AI 2027, there was sort of this notion of like, okay, and then we build AGI, and then like it's going to be totally crazy, and then like something happens. For example, like AI takeover or like maybe human dictatorship or whatever. but there wasn't really like an end-to-end story of like, okay, here's what the labs would be doing, here's what the governments would be doing, here's what the public would be thinking, sort of at every point through that scenario. And
Hmm.
I think AI 2027 was sort of able to be sufficiently high quality and sufficiently sort of in depth in all these
Yeah.
ways that it sort of covered that niche and let a lot of people like concretely grapple with what an AGI scenario might look like,
Yeah.
that previous work hadn't. And so I don't know. I think it seemed like a lot of people wanted to read that.
Yeah.
I'm hoping that that hunger isn't burnt out yet, and that we
Yeah.
can do future projects with better scenarios when we've
Yeah.
thought harder and gotten more evidence for the future.
Yeah.
And yeah, so I think our goal right now is to sort of just like keep producing better and better work to sort of keep snowballing that
Totally.
success.
Right. And then I guess, like, do you have some hope that, you know, in a world where maybe AI capabilities don't go super exponential super quickly, like the public will slowly wake up as they see, um, the next models from OpenAI and Anthropic, even, being even more impressive, automating more of software engineering or something. Like, do you have some hope that public discourse will evolve with the models? Yeah.
Yeah, I do. I think the longer timelines are and the
Yeah.
slower takeoff is,
Yeah.
where takeoff is sort of like the distance between these like AIs that are helping to automate the research process and AIs that are wildly better than humans at everything.
Hmm.
The longer everything takes, the more hope I have for broader societal wake up. Like in a fast scenario, like AI 2027, it seems like there's just not a lot of time for people
Yeah.
to update
Yeah.
and to change their mind and to do things like vote in elections for
Yeah.
candidates that have better policies on AI. There's
Yeah.
just not election cycles happening, and so you can't really do that. Whereas if it's really slow, I think things look a lot better. I think people wake up. I think there's a lot more time for governments and society more broadly to sort of like make itself robust to AGI.
Yeah.
And I think I think a lot of what government should do to manage the fast takeoff world is to basically slow down takeoff and
Yeah.
extend it and make it such that maybe it would have been a 1 year takeoff by default, and instead now it can be a 10-year takeoff.
Yeah. 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 Super interesting. Super interesting. Yeah. So I guess like touching on that point then, maybe let's like talk a little bit more about this idea of like an intelligence explosion that gets discussed in AI 2027 that sort of drives like that exponential curve up, and that's when takeoff speeds reach like speeds that we've never seen before. So I guess when we talk about this from like the perspective of AI 2027, we see that this iteration from Agent Zero to Agent One is this step up in the fact that Agent One is now great at helping with AI research, right? So put simply, this idea that AI models get more and more capable as until we reach a point where AI themselves are directly contributing to the AI research and development itself. I guess talking about that being this main driver behind intelligence explosion, is that how you would describe it mostly, or are there any like crucial nuances that you want to highlight when we introduce this sort of main driver of this like exponential curve increase to our listeners?
Yeah, I mean, I guess I'd say like, so in AI 2027, we sort of sketched out this like particular takeoff path where it lasted something like 8 months, the
Mm-hmm.
takeoff period between sort of the start of like substantial automation of the AI process to substantially superhuman AIs. And I guess one important point is we're extremely uncertain. We've tried to model this length of time and exactly how the AIs would speed up the AI research process, but it could easily be much, much faster, right? It could be a month, it could be a couple weeks.
Yeah.
Um, it could also be much, much slower.
Yeah.
Could take a decade.
Yeah.
So we don't feel like we have good models. We don't think anyone has good models of exactly how fast this will go or like a good
Mm-hmm.
understanding of the process. And so, uh, yeah, I don't know. I think that leads to stuff like it's good for us to continually track sort of how fast things are going,
Yeah.
and it should lead us into thinking, okay, this is like maybe a plausible scenario at 2027, even if it's faster than my intuition thinks. But you know, it should not lead us to confidence that that's the exact right scenario and that it won't, reality won't look, much, much slower, much, much faster.
Yeah. Okay. Okay. And so In my reading in preparation for this, I came across this idea of not only a software-driven intelligence explosion, but also like a software/hardware-driven intelligence explosion. So to make that clear to our listeners, like AI 2027, this scenario that Thomas wrote, imagines a scenario where AIs are automating like the software aspect of AI. They're like training the models and making them better. But there's also the possibility that AIs could be used to increase the amount of compute that we have available to train these models. And as we've talked about, compute is like one of these main drivers of AI progress. So why did you in AI 2027 choose to focus solely on the software-driven intelligence explosion? And was that sort of is that related to takeoff speeds? Like
Yeah.
this would go faster? Yeah.
Yeah, totally. So it's extremely related to takeoff speeds.
Okay.
So basically what we think will happen is that the AI labs will start trying to do a software only intelligence explosion. And the reason for that is it's way, way, way faster and easier for your AIs to change the software than it is to change the hardware.
Yeah.
Because with software, you can just, change some lines of code on your computer
Right.
and then propagate that out to all of the AIs running in all of the servers,
Right.
basically immediately.
Yeah.
With hardware, there's this very, very lengthy process of, building new fabs, designing new chips, producing those new chips at scale. That takes years, right? TSMC Arizona, I think, was a fab that is a chip fab that's trying to get produced in the US.
Right.
I think has been under construction for years, and they
Yeah,
still haven't
okay.
been able
So long,
to.
yeah.
They still haven't been able to actually get it to start,
Yeah.
printing chips yet.
Yeah.
So basically, if you can get the software intelligence explosion to work, you want to do that as an AI company because that's way, way faster, right? That could happen, on the timescales that we're talking about of less than a year.
Right.
If that doesn't work, then and we think it probably will work. The software only stuff, we're not sure. It sort of gets down into some very complicated, like long list of considerations.
Yeah.
If it doesn't work, then you're forced into a hardware, a plus software intelligence explosion. And what that looks like is you have AIs helping you build better chips and potentially also helping automate the economy broadly so that you can invest more into chips, right? We're already, I think, in the hardware plus software intelligence explosion world, you're probably also sort of automating the whole economy in order to make the economy as a whole much, much bigger so that it can support a much bigger semiconductor industry.
Yeah.
And that's sort of necessary to make the math work out of having like if you want to have $100 trillion semiconductor industry, you need to have a much, much bigger economy as a whole.
Yeah.
So in that world, things look much, much slower because you have to sort of eat these several year delays, these regulatory delays, these, delays in like sourcing all of these complicated like lasers and chemicals for etching your silicon and whatnot. That's just, it looks like a qualitatively very different scenario if you're also needing to do a hardware explosion.
Right. Totally. I guess taking a step back then there, when you think about both like this software development and also this like hardware development there, thinking about this from the perspective of what is driving AI capabilities these next several months, next several years. On the hardware side, we think about compute, right? On the software side, we're thinking about these like progressions in algorithmic and progression in algorithms in general. So are those like the two main like drivers that you would think about when you think about the improvements in AI capabilities, or is there other things that are also sort of like driving this change?
Yeah, I think that's a reasonable factorization into sort of compute and algorithms. You can break down the compute further. The compute one sort of turns into like Moore's law type increases, which are like here's how much compute you can buy for $1. And then there's also the just increasing the dollars.
Right.
And most of the progress is happening not from Moore's law right now. It's happening from increasing the dollars.
Yeah.
And then the software, you can break that down into, are you improving, the data quality? Are you improving the RL quality? Are you improving, the utilization of the compute, right? So like right now during training, I don't know, and because I'm not at a Frontier AI lab, and the Frontier AI lab people can't say publicly, but I would guess that the utilizations of the GPUs are maybe 30 or 40% during training. And so most of the time, the GPUs are sitting there idle. I mean, they're not actually sitting there idle. They're sitting there, bottlenecked on, memory getting from this part of the server to that part of the server. And so they can't quite do the computation yet.
Yeah.
And so like things like increasing the utilization of the GPUs, like there's some alpha there.
Okay, okay. And so why don't you distinguish between data and algorithms? Like some people say that we're hitting a data wall, and LLMs have already been trained on all of the data on the internet. There's no more data to be had. Yeah, I noticed you didn't mention data as distinct from algorithms.
Yeah. So one thing that's nice is you can sort of operationalize algorithms as here's how much capability you're getting per flop, right? Where flop is a unit of compute.
Yeah, right. Yeah.
And that sort of bakes in all of these different factors, including
Sure.
data, but also including like, whether you're doing PPO or GRPO or whatever is your RL algorithm.
Yeah.
And so that sort of formalism, which I often think in sort of just implicitly bakes these two things together. Of course, data is tremendously important.
Right.
And it might be true that we're hitting a data wall. I think we're probably not, because you can synthetically generate data by having AIs do tasks like for example, solve this coding problem, and then you take the trajectories produced by that AI that worked, and then you're like, hey, these are trajectories that worked,
Right.
and then
Right.
you train your next AI on them, and so you can basically get your AIs to generate data for the next generation of AIs, and that's called synthetic data.
Okay.
Yeah, I don't know. I'm pretty optimistic about that process yielding more capabilities. It seems like that's yielded a bunch of capabilities recently.
Yeah.
But of course, it might bottleneck.
So this formal definition that you're using for compute allows you to throw in this consideration of hitting a data wall in with all of the other considerations that we might have, like maybe LLMs aren't the true way to get to AGI. Maybe we run out of data, but it's just one of these things that would limit the effectiveness of compute in the long run, right? That's sort of the idea.
Yeah, that's right.
Okay, cool.
Yeah, that's right.
Okay. Cool.
Okay, so let's jump into misalignment in a little more depth. I know we mentioned it earlier. But yeah, so for our listeners who have never thought about AGI to a significant extent, can you introduce the risks associated with AGI, specifically misalignment, I should say? So if we're building these models, why is it so hard to make them align to our interests and our goals?
So yeah, so one thing I'll say is actually I think we don't know how hard the alignment problem will be yet. I think we don't have great evidence. So yeah, some key background on the alignment problem is the way these AIs are built is basically you take a giant neural network that's randomly initialized. So it's a giant set of numbers. The current models are often hundreds of billions or trillions of parameters, which are like the numbers, which are just numbers. And you like randomly set those numbers, and then you basically stir them around with gradient descent in ways that we don't understand until they, start outputting good performance on the, training sets. That's a very, very simplified view of what training is. But it means that we do not understand exactly what the patterns are that are going on that are leading to good performance in our AIs, similar to how we don't understand how the brain works.
Yeah.
Right. We're kind of like, I think we're evolving them, or we're like right. breeding. It's sort of similar to breeding animals, where you can sort of see, hey, how good did this dog end up at running quickly? But you don't understand, the internal mechanics of how the dog brain or the, dog muscles work, right. Except at a high level. Yeah. So that's, I think, very, very key background. And then the other key background is this intelligence explosion thing that was happening, where right now humans are, responsible for designing the AIs and are leading, pretty directly to almost all of the improvements in algorithms and hardware. In the future, specifically during the intelligence explosion, that will stop being the case. And AIs, instead of humans, will start being the main reason that capabilities are increasing and are going to be like the primary driver of the next generation of AIs. And so once you start to have AIs that are like basically entirely designed by other AIs as opposed to by humans, I think the risk that these AIs, make a mistake and do something that wasn't intended by the humans goes up by a ton simply because you don't have any humans in the loop for this process.
Right.
Um,
Yeah.
and then I think maybe the third thing I'll say is that, and then at the end of this intelligence explosion, sort of what you get out of this process is this wildly superhuman AI. And I think this AI will have very, very high capabilities. I think people almost always underestimate what superintelligence will be like in terms of what it can actually do. I think we sort of don't have good upper bounds on capabilities for like what AIs could do in principle,
Right.
and or the ones we do, the physical limits of intelligence, they just look really, really, really high. It looks like the brain, does not, efficiently use computation very well, and it seems like computers could do so much better.
Right.
Sort of an analogy is like think about a plane versus a bird, where like the super intelligence is like the plane because it's like designed and optimized and like huge amounts of industrial resources are put into making it good, whereas the plane is this, or the bird, sorry, is this hacky thing sort of produced by evolution randomly.
Yeah.
And so we should expect this super intelligence to be like really, really smart, really, really good at doing things, and therefore really scary if it had bugs in its motivational drives or alignment problems. And so sort of the root of the concern, I think, is those things all happening and then leading to AIs that have some sort of goals. Very, very hard to predict exactly what goals AIs might end up with out of this process, but there aren't really good reasons to expect it would be like exactly the right goals, like notably like aligned to the best interests of all of humanity. And therefore, we should be very worried that those goals are, not what we want them to be.
I'm interested in this thing you said about like your uncertainty regarding how difficult alignment will be, right? So why don't you take the examples that we've had, like under the status quo, like we have LLMs that aren't doing exactly what the model providers are intending. They're like, encouraging people to do horrible things to each other and stuff. You also like on the other hand, we haven't solved alignment, and like my understanding is that people in like the technical safety community don't think that we have a clear, promising solution to alignment. I mean, you worked at the Machine Intelligence Research Institute doing alignment research. So why don't you take the recent history of alignment research as evidence towards alignment being very difficult?
Yeah. So, okay. So maybe I'll say two things. So the first is, yes, there are definitely lots of instances of the models not doing what we intended. Like, Grok, the Grok Mecha Hitler incident was a very famous one, right?
Notably.
Where Elon Musk's AI on Twitter kept, talking and tweeting about Mecha Hitler. And yeah. So there are definitely instances of AIs, not doing what the creators intended, but by and large, AIs, in fact, do what we intend right now, right? Like most of the time, you can go pull up ChatGPT and ask it to like do a homework problem for you, and it'll just go do the homework problem for you. And so I would say that most of the time, AIs right now are instruction following, and that's a good sign. It would be a much more worrying sign if the AIs were, constantly trying to go rogue right now. And right now, they seem to like very rarely, but sometimes go rogue and do, unintended things. And the second thing I'll say is that I think there's a good chance we can get a lot of useful AI labor on the alignment problem during the intelligence explosion.
Right.
And this is a very, very scary hope, of course, because if the AIs are misaligned, they obviously won't do a good job at alignment research for us.
Right.
But I think there's a chance that the early AIs that are sort of more similar to the current AIs are sufficiently aligned, but also sufficiently capable that they don't do egregiously bad actions while doing somewhat useful work on things like alignment for us.
Right.
And that could end up snowballing into a good solution that actually scales all the way to superintelligence, where I think the current solutions that are actually on the table, what we currently do to align the AIs, I think there's almost no chance that works for the superintelligences. But there's a lot of time between now and then. Maybe we could come up with something. Maybe the AIs helping us can come up with something that aligns to superintelligences.
Yeah, totally.
That's the bull case.
I think
Hopefully the bull case is right.
for all the sakes of us. I think there's also this interesting point that you mentioned in the paper um, that seems to make alignment or misalignment of the model difficult for the model itself, in the sense that you talk about how there's like this advanced agent that has to be careful as it trains a human misaligned, even more advanced agent, right? So this concept that the task for these agents is to misalign and then train further models to be misaligned to us, but aligned to them, that seems like relatively complex and a daunting task. So when you think about like misalignment as a general, do you see like that specific sort of task itself, maybe like a positive signal for us? And can you kind of explain that dynamic there a little further?
Yeah. So I think that was one of the things that I was actually happiest we gamed out as the process of writing AI 2027, because I
Mm,
think we thought a lot more carefully about the AI's perspective and like
yeah.
suppose you were a misaligned AI, like what would you actually need to do in order to achieve, hypothetical misaligned goals? And
Okay.
one of the key things that a misaligned AI might need to do, which you just said, is figure out how to, solve its own alignment problem. So figure out how to align future AIs,
Yeah.
but then screw up the goals such that the future AIs are aligned to its goals as opposed to
Yeah.
the humans' goals, and
Yeah.
that the combination of like solving the problem but not explaining it to the humans and like tampering with the goal that you're trying to put into the future model is like that's a complicated thing that sounds pretty difficult for uh, an AI to do.
Yeah.
And I think
Yeah.
that is indeed like that's one of the reasons that I have some hope. And I think that like leveraging things like that to, you know, really, if you like are really watching your early AIs very, very carefully to see if they're trying to do suspicious looking strategies,
Mhm.
like, you know, uh, like giving you a fake solution to alignment that seems like it would align the future systems to the AIs as opposed to the humans. Like
Yeah.
if you can like look carefully and have humans at least sort of in the loop the whole time, or at least for as much as you can, I think there's like a reasonable chance we can get through it pretty quickly, and successfully.
So, so that's interesting there. So on this concept of having a human in the loop and sort of like understanding and being able to interpret sort of the processes and thoughts, quote unquote, of like these models to make sure that they're aligned or not misbehaving in any specific way. Another concept or discussion that was raised is about how models have this potential to communicate not in natural language, right, but just in these sort of crazy matrices of numbers, right, known as like neuralies. And the thought process behind it is that this would significantly speed up AI's thinking and communication, which could, um, be part of that sort of fast takeoff speed. But on the flip side, it would make their thoughts less interpretable to humans. So, when you think about that process on sort of like based off of what you said, are you sort of against moving this like transition? Um, and if so, like, is it sort of inevitable for the development to sort of take off?
So I kind of feel like I kind of feel like an old man yelling at cell phones or something if I were to sort of have that position. And what I mean by that is I think probably what we call neuralese, like this, moving away from like our AIs thinking in English, will
Mm,
be inevitable for capabilities reasons.
mm,
I think it's probably just not going to be feasible for AIs to continue thinking so clearly in English, and
yeah,
that it will just be so strongly incentivized to think in these like giant matrices of numbers, and that you can
yeah,
just do so much more efficient computation in that format than in English.
yeah,
On the other hand, I also agree with what you said that that there are a lot of alignment benefits. There's a lot of monitoring benefits to keeping it in human readable chain of thought
yeah.
in English. And so insofar as it's competitive to keep up with English chains of thought, I'm very, very in favor of doing that. But I just don't think it'll be feasible in practice. And so unfortunately, I'm just like bracing myself for the incoming neuralies.
To get a better picture of like various approaches to alignment, my sense is that in the technical alignment community, there's two camps. One camp like thinks that there is some grand theory of alignment that can be solved, and then once you've solved it, it like works all the way up until superintelligence. And then there's the other camp that you seem to be in, where it's like we just have to align the first generation of like ASIs or whatever, and then they can continue to like refine alignment. Or so rather, like even the first generation wouldn't have to be fully aligned. They just have to be like somewhat aligned. And then as long as we were making sure that they were doing alignment research, like we'd be getting closer and closer with successive generations. Yeah. So, like, do you think it could go either way, or are you like pretty convinced that there's no grand theory of alignment and like the way to do this is to have our AIs do our alignment homework for us, so to speak?
Yeah. So I think I'm more sympathetic to the first camp than maybe I
Oh, really?
than maybe you think.
Okay.
So I think Eliezer Yudkowsky is sort of probably the most famous proponent of the idea that you you sort of need to like fully solve alignment, and the handing off of AI alignment labor to AIs
Yeah.
will not work as a
Yeah.
plan. Um, I think that's very possible. I think my disagreement with him is more on the can you get useful labor out of AIs part than it is on the we'll eventually need a complete theory of how everything works and of alignment, and that
Okay.
that theory will be scalable.
Okay.
So I think my view um, is more like a combination of the two views, which is that uh, you can leverage early AIs to do lots of labor
Mhm.
for alignment research and for other good things that help the world. Um, and that eventually you probably need to move to this point where these sort of like janky empirical solutions
Yeah.
to alignment, or like at least like approaches to alignment, which we currently use, are not sufficient, and that we'll
Mhm.
need something more like a theoretically clean solution.
I see.
And I think that was reflected in AI 2027, because in that scenario, what happened was we sort of in the ending where we solved alignment, uh,
Mhm.
we started with these sort of like janky alignment,
Mhm.
and then the AI ended up like doing this like complicated reverse engineering and distillation of the
Right.
model into a like fundamentally interpretable architecture, which was like
Okay.
a wild paradigm change that
Yeah.
is like extremely different from how we currently train AIs.
Yeah.
And this led to scalable alignment all the way to superintelligence.
Yeah.
Um, and I think that even though it might not seem that way, even Camp One people like Eliezer, I think are quite sympathetic to like having a multi-stage plan. So my understanding of Eliezer's plan right now
Mhm.
is even he's into something like do human augmentation. So do
All
something
right.
like
Yeah.
figure out how to upload the humans, and
Yeah.
then have the humans in their uploaded environments work a bunch on alignment, and then
Yeah.
those AIs will like hand off to maybe corrigible AIs, and
I
then those
see.
corrigible AIs will figure out how to do like a more robust philosophy type thing, and then
Yeah.
have the AIs like have like actually philosophically uh AIs that are aligned to like the philosophical notion of the good or whatever.
Mhm. Mhm.
um and so like even he is sort of into this like multi-stage process. He's just more pessimistic about approaches that leverage machine learning relative to other approaches like human intelligence augmentation, which like would rely on longer timescales and probably
Yeah.
be not competitive from a capabilities perspective with ML.
And I guess on that point, then, when you're talking about these sort of like hacky solutions, um, that might not sort of fit this paradigm shift. When you think about these labs like OpenAI and Anthropic, have you seen any sort of like promising approaches, or do you just believe that as of right now, every solution that's sort of being worked on is hacky and won't sort of fit this new paradigm that's going to be sort of like happen or that happens that won't be able to be rely on these solutions that are being worked on right now?
So I think yes, I think that basically all of the current things that are being worked on will not scale to.
Yeah. And what are those things, if you could kind of like briefly cover a few of them?
Though actually, sorry, I also want to say that I still think that of course they're very helpful,
Yeah.
and that like aligning the intermediate AIs, even if you haven't one shot aligned superintelligence, is still very helpful.
So yeah.
So yeah, let's talk about the agendas. So some of the agendas that I think are exciting are things like um, interpretability. So
Mhm.
trying to figure out how the AIs work.
Mhm.
So this is like you take sort of the parameters, which are kind of like the neurons of the AIs, and look at them and be like, which well this weight this neuron equivalent, this parameter, like lit up when the AI was thinking about this problem,
Yeah.
but not this problem. Therefore,
Yeah.
maybe this parameter is like, tends to be thinking about, bananas.
Yeah.
And then you can sort of, through that, at least in theory, build up a like detailed understanding
Right.
of how exactly the eyes work. I'm
Right.
very into that. I think people have been making a bunch of progress in interpretability. I
Hmm.
think the progress has been slow,
Hmm.
and at least under short timelines, I don't expect it to get to the point where it's like meaningfully contributing to
Yeah.
safety cases.
Yeah. Is it because of a lack of resources there though? Like, are you attributing this mostly because there aren't enough like resources, whether that be talent, whether that be compute placed into these issues themselves, versus like all of it really being centered around capabilities? Or do you really just think that, some of these solutions just won't work because inherently those solutions aren't fit for this like new shift?
I mean, a bit of both. I think interpretability is just fundamentally probably an extremely hard problem.
Hmm.
Um, and yeah, I mean, a number of solutions are, or a lot of effort is being put into it, but not enough. It'd be great if there was, 10x or 100x more effort put into it.
Right.
Um, so maybe I'll list off a bunch of other AI alignment agendas, and you can ask about any of them that you're interested in.
Yeah.
So
Totally.
there's stuff like making RLHF or RLAIF
Hmm.
better. So this is like using AIs to supervise other AIs and like
Hmm.
grade them and make our like reward functions better.
And RLHF, just for our listeners, is reinforcement learning with human feedback.
Yeah, that's right. Um, there's stuff around there's stuff around evaluations. So thinking about so trying to understand how smart our AI systems are and
Mm.
like what types of threat models they'd be able to execute. So there's stuff like evaluating dangerous capabilities. So like, could our AI build a bioweapon? Could our AI do a
Hmm.
cyber attack? Could our AI, you know, uh, persuade people of X,
Right.
etc. Uh, there's stuff like control. So this is like, instead of aligning our AIs, maybe we can prevent our AIs from causing catastrophe, even if they're misaligned. So
Right.
this stuff is like, monitoring AIs during inference time, um, limiting AI permissions so that they like, don't have access to like various dangerous things, or like heavily surveilled when they do have access to potentially sensitive data or code. Um, there's sort of like a whole bundle of like control things there.
Yeah.
There's model organisms research. So that's sort of like creating examples of AIs being misaligned so that we can study them in the lab that are
Uh,
as realistic as possible. So there's sort of all these hypothetical behaviors like that the AIs might have in the future. So like, for example, they might alignment fake. They might be deceptively aligned during
yeah.
training. They might pretend
Yeah.
to be aligned during the training process so that they get deployed and then they can do whatever evil thing they want to do during deployment.
Right.
You
Yeah.
can create sort of like fake contrived examples of that right now and then test it and be like, okay, suppose our AI was deceptively aligned. Could we catch it? And if you have a model organism, you can actually like sort of have a test bed for
Yeah.
that.
Yeah.
Um, there are things like probes, like you can sort of like train well, so sort of one advantage that we have for AIs as opposed to humans is that we have like full read write access on the brains of the
Right.
AIs, where we
Hmm.
can't, we can do our sort of sketchy MRIs on the brains, but they don't give you the whole state. Whereas we just directly have access to the whole state of our AIs.
Yeah.
And so we can do stuff like build probes that just read off that state and tell
Yeah.
us if something scary is happening. And we
Yeah.
could do things like train those probes with model organisms,
Yeah.
uh, or various things we've gotten off of interpretability. So we could train
Yeah.
probes that sort of trigger when models are thinking about scary things like deceiving humans or exfiltrating its model weights or
Yeah.
whatever.
Yeah. Yeah. So given all these like sort of solutions that are out there, under the assumption that right now, not enough resources are being spent on these like sort of areas of research, do you have a sort of idea of when you would characterize a situation as too late for these labs to act anymore? I guess another way of thinking about it is, how long do you think these labs need to match these safety innovations to the capability innovations that we're seeing right now?
Yeah. So So okay, there's one version of your question which is like, what's the point of no return? Like how,
Yeah.
like, what's the point at which the AIs, the AI labs can no
Yeah.
longer intervene to make.
Yes, like what? Yeah. Is there a point where like the delta between capabilities and safety innovations is too large, where we can't return anymore? And how, I guess, do we identify that point?
Yeah, so I would say that point is probably a bit beyond the point of full automation.
Okay.
So I would say that once we're at the point where OpenAI is basically being entirely run by AIs as
Hmm.
opposed to humans, we're probably cooked if the AIs are
Hmm.
misaligned,
Yeah.
unless we've made some sort of advancements.
Yeah.
Um, I think that with if we implemented to the best of our ability all of the known AI safety techniques, like especially I think all of the control techniques,
Hmm.
then I would say that this sort of pushes out the point of
Hmm.
like the point of no return. Let's
Right.
say
Yeah.
I'd say it maybe points pushes it off to the point of like superhuman at everything. Right. I
Right.
think that we could maybe monitor AIs that are even just barely superhuman.
Yeah.
But I think once they're like wildly superhuman, even the control measures won't be sufficient.
Right. Okay.
So you're saying if we have a mechanism for monitoring and controlling how these AIs are interacting within an AI company, then we can get a lot of like alignment labor out of them, even if they're not alignment and capabilities labor out of them, even if they're not fully aligned, like to humanity, right? So
Yeah,
is that
that's
the
right.
idea? Okay. Okay.
And critically that like we'll still be able to turn them off even if they're misaligned. Like
Okay. Right.
we won't cross some sort of threshold where they're sufficiently good at cyber that they can leak their weights or persuasion such that they can like persuade us to do whatever they want.
Right.
um and I think there are known precautions that would sort of dramatically increase the capabilities point at which we like reach the point of no
Sure.
return,
Okay.
where like the without mitigations I think the AIs might just have a much easier time of taking over
Right.
than if we just like actually installed the mitigations that we know about right now today without
Yeah.
doing any more research at like all of the frontier AI labs.
okay, makes sense. Okay, moving on to another category of risk, we have misuse risk. So I guess we'll maybe spend a little less time on this section, but I'm interested in why you chose at the AI Futures Project when writing AI 2027 to focus so much on misalignment and like relatively little on misuse, right? Like it seems like I remember in the scenario, there's a point where like, okay, we have, I don't know, Agent 2 and it's insanely powerful in terms of cyber capabilities. And there might be some potential for jailbreak, like probably it's robust to jailbreaks, but we're not really sure. But like if some hostile actor jailbreaked this insanely powerful model and like got it to do to perform some sort of cyber attack for it, then like that's another way that humanity could be completely screwed if we have all of these random rogue actors shutting down our power grids and inciting war. I mean, whatnot. So yeah, I guess the question is, why do you choose to focus more on misalignment risk rather than misuse? Do you think misuse is like more solvable, or like you're less worried about that being something people overlook? I don't know.
Yeah. So first I'll say I think one of the key aspects of misuse risk is I think this concentration of power risk,
Uh-huh.
which is this like risk that uh, the AI developers themselves will misuse their AIs and
Uh-huh.
do bad things with their own AIs. So I think I'm for example worried about the scenario in which like an individual lab builds an AI and then gets a lead over the rest of the world in AI capabilities and then uses that AI to like literally take over the world. And
Mhm.
I think that's like a central example of misuse risk. And
Okay.
something pretty close to that did happen in, the slowdown branch of AI 2027.
Right.
So I think that's so like, in some sense, I think we did sort of
Sure.
outline one misuse risk scenario. So why not the other types of scenarios like maybe an AI generates a bioweapon because some terrorists wanted to, do
Yeah.
bioweapon
Yeah.
AIs and
Yeah.
cause a lot of damage.
Yeah.
I think that's a very plausible and very important scenario. And in some sense, we're just like bottlenecked by capacity. The reason we chose to focus on the misalignment and concentration of power type threat models is because we think they're a somewhat bigger deal than the misuse type threat models. In particular, once we have the type of AIs that have the capabilities to do catastrophic misuse, like go off and build a bioweapon that would be like much worse than COVID, and then figure out how to print it and deploy it and
Yeah.
whatever like
Yeah.
full stack capabilities. Probably that AI is quite close to just you know doing the intelligence explosion.
I see. Yeah.
And once the intelligence explosion is happening, like I think it's just like a much bigger problem
Yeah.
than the misuse AIs.
Yeah. Okay. Yeah.
Um, but of course, misuse AIs is pretty important too, and also the mitigations for misuse stuff does seem a lot more tractable
Uh,
than the mitigations for misalignment stuff, right?
yeah.
If we
Makes sense.
just, I think if we keep AIs you know deployed via APIs as opposed to via open source, if we make them harder to jailbreak, if we put in good model specs that do appropriate refusals for dangerous
Yeah.
like misuse type actions. I think
Yeah.
that stuff's all pretty conceptually straightforward and
Yeah.
would go a long way to mitigating misuse risk.
Yeah. Totally. So I guess on that point of then concentration of power, um, you guys like talk a little bit about it from the perspective of the people who do create the models themselves, the researchers taking that sort of power, but also this potential for the government taking this power and keeping it in the hands of, like, for example, the executive branch that you guys focus on. And I guess, so when we talk about this country of geniuses in a data center, are you sort of more worried about, I guess, like the private aspects of things with the researchers themselves holding and keeping that power? Or are you more worried about like the government, the executive branch taking over and then sort of that being the issue when it comes to the concentration of power?
Yeah. So great question. I think this is dependent on takeoff speeds. And
Yeah.
under my views on takeoff speeds, I think we should be more worried about the researchers
Mm-hmm.
because I think the default scenario is that the government is just asleep at the wheel and doesn't understand the AI capabilities,
Mm-hmm.
like that the intelligence explosion is happening and that AI is the only thing that matters
Mm-hmm.
until it's too late. And in that scenario, if we solve alignment, then basically the CEOs of the labs end up with all the power.
Mm-hmm.
And under a slower takeoff scenario, I think it's much, much more likely that the government wakes up and then the government has time to intervene and do things
Yeah.
and to basically take power from lab CEOs and make sure that the AIs are aligned to themselves.
Yeah.
Um, and I think that's, obviously I have a lot of uncertainty over takeoff speeds. And so, if takeoff becomes, a few years or 5 years or whatever, then I think like government type concentration of power scenarios look really scary. And yeah, so they're also important.
Yeah.
Okay. So isn't a crucial point here that the AI companies wouldn't necessarily have to deploy their models or release them to the public? So like you're saying if like takeoff speeds are really fast, OpenAI or OpenBrain could have like insanely powerful models in house that they don't release to the public, so the government wouldn't be aware of how powerful the models are simply because OpenBrain is like keeping them to themselves, which is like obviously not what we see right now. Right now, there's like relatively little lag time it seems between models being developed and models being released. So is that a crucial point for the U.S. government not waking up, or like?
Yeah, I would say that is a
Okay.
pretty crucial point, but also that during the intelligence explosion, the trajectory might just be so fast that even a very small delay, like a couple
Uh,
months delay, might be
uh,
critical.
okay.
And currently like several month delays between internal and external deployment of AIs is very common.
Okay, interesting. Okay, in our last 20 minutes or so, we want to move on to governance. So to introduce, I guess, the different ways that we can talk about AI governance, the discussion can be separated into two categories. There's sort of like current policy actions that the U.S. government can take right now, with model capabilities being as they are, and then there's sort of policy actions or discussions that prepare the U.S. government to deal with this intelligence explosion that we haven't seen set in motion yet. So I guess like, how do you think about, insofar as you're trying to maybe make some recommendations to policymakers in the future, how do you think about balancing your efforts in terms of like actionable things that we can take right now to mitigate existential risks versus mostly focusing on waking up people to the prospect of an intelligence explosion and like gaming out what they should do in that scenario?
Yeah, I mean, I would say a bit of both. So I would say on the preparing side, like I guess on like the preparing directly for AGI side, I think the some key actions are stuff like getting ready to slow down, in particular, build verification mechanisms so that we can verify a like coordinated agreement with China and with other countries. And like that's a very like low risk, low cost action. It's literally just like invest in building that technology so that it's
Mm-hmm.
ready for later if we
Yeah.
want to do that action. So it's just
Right.
creating optionality for later.
Right.
In terms of the like waking up the world, I think yeah, a bunch of the policy there is just like try to make sure that there isn't a giant gap between internal and external deployment.
Okay.
So things like, so today, in fact, today as of the recording of this, SB 53 in California, the state bill regulating AI, or I think making AI somewhat more transparent,
Mm-hmm.
passed and was
Right.
signed by the governor. Um, and I think that bill looks good. And of course, it's only a very 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 small step in my mind,
Mm-hmm.
but it basically, creates minimal provisions requiring companies to at least disclose like very very basic data that they have on AIs that they produce, and I
Mm-hmm.
think that like helps in a intelligence explosion type scenario to make sure that the government and the public have some idea of what's going on.
Yeah. Yeah.
Okay. And in addition to transparency, what are some other like policy actions that people could take right now that you would hope to see implemented?
There's a lot of government capacity stuff. So
Uh-huh.
like right now, there are just very, very few knowledgeable federal employees with respect to like the state of frontier AI development. And
Sure.
so I think it would be great if we basically just like hired a bunch more people who like really, really, really knew the details of AI
Uh-huh.
into the federal workforce.
Uh-huh. So I guess like then on that point of the government having more oversight or control over like what's going on at these frontier labs, there's this concept of soft nationalization where the government slowly increases its command over the industries or the leaders of these industries. And I think like, talking about like what you said there, like under the status quo, it seems somewhat hard for to imagine the United States completely taking over an entire industry. But on that point, then, do you think, in the next several years, is that sort of like soft nationalization inevitable in a sort of successful situation? And, I got a follow up there. What would be the main actions that you would predict the government to take in this sort of soft nationalization process?
Yeah. So I think it's not very likely because I think the government is
Huh.
not
Okay.
very woken up to AGI
Yeah.
and therefore will mostly not do anything
But
major.
JD Vance read the paper.
Yeah, yeah, maybe.
Okay.
Um,
Maybe.
and situational awareness. So obviously, so I think you might be referencing the situational awareness
No,
thesis there.
I'm referencing the Ross Douthat podcast or Douthat, whatever. And JD Vance said he read A 2027.
Yeah. So it's true, but the predominant vibes around DC, I think, is extremely skeptical
Okay.
of like fast AI progress or AI capabilities. And also like government capacity is just pretty low right now. Like the
Yeah.
US government just tends to be pretty bad at doing things. And so I think it's pretty unlikely we get even a soft nationalization.
Really? Okay.
Um, it's possible, of course, but it's I don't think it's that likely.
Yeah.
Um, and what would it look like? Well, I mean, I think the most likely way is basically like all of the labs just become more like, Lockheed Martin or Raytheon, where they just become like sort of more intense government contractors.
Yeah.
And so they become like much, much more in the loop. And then like the US government uses the contracts as like a lever to like get the companies to comply with like various things they want the companies to do.
Yeah. Yeah.
Um, another way it could happen is um, what happened in AI 2027 in the slowdown branch, where the government used the Defense Production Act, which is sort of like World War II wartime authority, to uh, basically like take away a bunch of their computational resources and like
Mm.
reallocate that to either a centralized project or to another lab, which is more
Yeah.
favored by the government.
Yeah.
Um, and that's like, I think that would be very legally debatable. Like it'd be very, it's, I think people I've talked to are very mixed on
Uh,
whether this is legal.
okay. Well, I'm not sure that matters right now, but
Yeah, yeah. So I don't know. I think it could happen. It could not. Yeah.
okay. Then why did you choose to write about like soft nationalization in A 2027? If you think it's unlikely.
Um, well, I don't think it's that unlikely. I don't know. I
All right.
think it's maybe more like maybe it's like 20-25% likely.
Okay.
It's not like 1% likely.
Mhm.
Um, and conditional on something like the slowdown ending happening, I think it's reasonably likely.
Mhm. I see.
I think that overall, like the race ending in AI 2027 is like substantially more likely to happen than the
Uh-huh.
slowdown ending
Yeah.
because it's pretty unlikely, like because of that exact reasoning. But
Yeah.
like once you have a bit of a slowdown and once you have a bunch of like some government involvement in AI, I think that would be like a reasonably likely step.
Okay.
I
Yeah.
don't, of course, like I want to be clear that I don't think this is necessarily a good policy.
Mm.
I think that a Manhattan Project could very, very easily be very, very bad for the world.
Mm.
In particular, it could help lead to like the U.S. president getting a huge amount of power.
Yeah. Mhm.
And also, it could lead to just like humongous incompetence
Yeah.
botching the alignment stuff.
Yeah.
Because I think governments right now just like often botch things,
Right.
and the Manhattan Project could just so easily get botched, and we might even like be in better hands in the private labs, even though the private labs aren't doing that great of a job at alignment right now,
Yeah.
simply because they have much higher quality employees.
So I guess maybe shifting perspective from internally to externally. When we think about like what our government is capable of in terms of nationalization and I guess the legalities behind centralizing everything, I think one natural question that comes to mind is when we compare the United States to China, sort of in this AI race. How do you sort of see the current state? I think especially we saw an uproar when DeepSeek released R1 around China's talent and state-backed scale. But also in AI 2027, I think you guys bring up an interesting point surrounding China's, I guess, political or economic ability to sort of centralize and really become this monolithic structure in a way where, the systems in the United States just don't condone. And so I guess like when you think about this race as a whole, how do you think China versus the United States compete now, and how could you see it like potentially compete later on these different levers?
So the main advantage we have is that we have way more compute than China,
Mm-hmm.
right?
Mm-hmm.
Like the US has something like 70% of the world's compute. China has
Mm-hmm.
something like 10% of the world's compute. We have
Mm-hmm.
exact numbers on the AI 2027 website, or well, more exact numbers than what I just said, which are our
Mm-hmm.
best guess. Of course, we don't know the exact.
Yeah.
Um,
Yeah.
so that's a huge benefit for the US because like compute is just like fundamental to
Right.
progress. And it
Right.
means
Yeah.
that China is something like 2 years behind on
Yeah.
compute. Um, and it's not just the stock of compute, the new production of compute is also way behind
Yeah.
because China does not have a very good domestic semiconductor supply chain.
Yeah.
Almost all of the world's leading chips are produced in Taiwan
Yeah.
by TSMC.
Yeah.
And like that's where NVIDIA produce their chips. That's where, the iPhones get produced. The chips that go on the iPhones get produced. Um, and those cutting edge AI chips are blocked by US export controls from being
Yeah.
sold to China.
Do you see that? Do you see that trend right there, specifically with Chinese semiconductor supply chains being being worse than United States ones, or like ones like that are coming out of TSMC, or companies that are building their chips in TSMC, like ever changing? I think like what we've been witnessing these last several months, or like more recently, is like where China's sort of giving backlash towards even buying these subpar chips from NVIDIA, for example, by accusing them of antitrust sort of obligations or things along those lines. And so I guess like is that a sort of a signal in the sense that China is starting to increase their capabilities when it comes to like their semiconductors or improving their supply chains? Is that where?
China definitely really badly wants to increase its semiconductor supply chain capabilities. And it's just going to be really hard for them
Yeah. Do you
because
think
it's
it's
just
not
very
likely?
hard
Yeah.
to make good fabs. I think it's possible. I think it'll take them a long time,
Mm-hmm.
particularly to make EUV lithography machines
Mm-hmm.
is like a very difficult uh, like component to make in the semiconductor supply chain. Um, and yeah, it's possible. I think over the long run, over like 10 years, I think China looks reasonably good, in
Mm-hmm.
particular because I think they're better at building energy than the US.
Right. Yeah.
And if they can just outgrow economically the US, I think things look pretty good for them
Mm-hmm.
in terms of AI.
Mm-hmm.
Under shorter AGI timelines, I think the US looks much better. given the commanding.
And on maybe the normalization of everything else, and we're just comparing research talent to research talent. I think when DeepSeek released R1, there was this notion where even with like significantly less compute, because of like the research talent, the algorithmic process from it, they were able to, cut the gap to only a few months between leading models in the United States versus China. Do you think that means that, like, when we talk about algorithmic process or what's being created by these researchers is in a better place in China versus the United States, or do you think that's, just media?
I think the US. I think I agree with you about the gap being a couple months at the time of the DeepSeek release. I think that the media overhyped it a bunch, and the gap has widened now. And the reason that the gap was so low is because the inference time scaling technique, which was like sort of the key technique that OpenAI had come up with, that was like very, very relevant for their O series of models, and then the DeepSeek models, was like just getting created and was therefore not very scaled up. And so it was therefore possible for DeepSeek with the tiny amount of compute to sort of replicate the results at similar to the Western scale. But that will never be true again, because now the inference scale is like much, much bigger, and is and DeepSeek is not able to replicate O3 levels of RL compute. Of course, there might be new paradigms that happen where DeepSeek is again able to match it on low compute. But betting just on like new paradigms that work in very, very small compute regimes is a very, very sketchy bet to make in AI, and like just seems worse than having all the GPUs. So yeah, it's possible, but I think the DeepSeeks and the Chinese AI companies are like quite unfavored with respect to the US AI companies in the near term. And then in the long term, of course, like once they get EUV machines, once they get their own domestic semiconductor supply chain, all bets are off.
Okay. So yeah, I mean, a few minutes ago you talked about how the U.S. government waking up to this and centralizing AI research in the U.S. is not necessarily a better outcome than the private labs continuing to have control. But it seems like that's the outcome that you're betting on, as like maybe the median outcome in that camp is better than the median outcome in the private labs just continuing to hold on to power. So is that fair insofar as that motivates your sort of next steps with making policy recommendations to the U.S. government and trying to wake them up?
I would say I'm very unsure. I would say I'm deeply unsure about whether a Manhattan Project or not nationalization type approach would be good or not. And therefore that my central recommendations don't involve a Manhattan Project, and instead revolve around things like getting ready to do coordination, or trying to improve the rate of AI safety research happening and stuff like that, which seems much more robustly good to me.
And so coordination, it would still involve some degree of power exerted by the U.S. government over the frontier labs, right? Because like they would be like, all right, we've signed this deal with China. You can't continue to progress capabilities. So, but that doesn't count as nationalization to you?
It might not involve centralization. So the labs could potentially stay as private companies and then simply be like
regulated.
Be regulated, all agree to whatever standards. Like, maybe all the labs agree to like not do Neuralese, for example. I think that'd be great.
Yeah. So I guess on that point then, in terms of your recommendations, and the next projects that you've been working at, AI Futures, can you outline the sort of main objectives that you think the United States government has to achieve to improve the chances of good outcomes?
Yeah. So I would say right now, the main things I want the US government to do is understand what's going on like today, which I think is difficult. And would involve the US government like doing a lot more stuff. So like I think right now, basically just like understand what's going on, hire really good people, get the relevant information, etc. And then I also, so that's sort of this like understanding what's going on. And then I think I also really want them to prepare and sort of get ready for coordination. And I think that stuff looks like build a chip registry, figure out where the chips are so that we could do, so that we could use the chips to enforce standards on AI progress, and get ready to do coordination via building that registry by building hardware mechanisms, which could be helpful for enforcing a deal with China.
What would that deal with China look like? Like what sort of agreements has to be made between China and the United States? Would that be slowdowns? Would that be extending takeoffs to sort of reach a point where we're thinking about AI capability research a little more safely?
Yeah, so one baseline agreement I would really advocate for between the US and China is, hey, we'll just like tell each other how capable our models are.
Hmm.
And we'll give each other sort of transparency, give each other visibility
Hmm.
into each other's AI projects so that we like know how fast things are going.
Yeah.
And we know that there aren't secret AI projects happening on the side that we have to worry about. I think already that sort of like basic agreement goes a long way
Yeah.
because it helps both sides basically be confident that the other side is complying with any additional agreements they make.
Yeah.
For example, like agreements about safety standards or whatever.
Yeah.
And I think eventually both sides will end up wanting to have a bunch of agreements about safety standards or like about like what goals the AIs might want to have or
Yeah.
like what economic impacts the AIs might want to have. And that like all of that basically gets built on like mutual understanding and verification of what's going on.
Yeah. So I guess like a concern there then is how can you ensure and enforce that there are no such secret AI projects going on? How is there like a confirmation of that visibility between two countries who are clearly trying to, quote unquote, beat each other when it comes to better capabilities?
I mean, so the basic idea is the current data centers are roughly the size of Manhattan,
Mm.
and it's very hard to hide Manhattan.
Yeah. Yeah.
Um, Particularly because like these data centers are filled with chips,
Yeah.
with hundreds of thousands of chips, each of which cost tens of thousands of dollars.
Yeah. Yeah.
Right. So these are just massive, massive scale infrastructure projects.
Hmm.
And so it's just really hard to hide them.
Hmm.
Um, of course, you might be able to hide small scale versions, but those data centers only be able to train way, way, way behind AIs.
Hmm.
So the basic proposal would be like find all the data centers, put inspectors in them,
Yeah.
and yeah, and I think that would work at least for a bunch of years. Uh,
How
for
about then?
decades, it's much more questionable though.
Yeah. How about then when it comes to capabilities research specifically then? Like for example, what if, United States is using compute specifically for training models versus necessarily just inference? Is there a way to sort of distinguish that?
Yeah, um, I think there is. It's a bit technical, so probably this isn't the right audience for this.
Okay, great. I guess just high level.
Yeah, high level. I mean, so basically there are proof of work schemes that I think would work for inference,
Hmm.
where you could basically prove at a technical level, like, hey, the computation that we did on this server is doing inference,
Right.
uh, and not is like doing inference, which is like serving, which is like giving ChatGPT to users, as
Yeah.
opposed to like training a totally new model.
Yeah.
And those computations like look pretty different, and we think that there are, uh, in fact, algorithms that you could use to distinguish these two things.
Yeah. Yeah.
Makes sense. Okay. In our final few minutes here, we have some like final wrapping up questions for you. I guess one is like overall, how optimistic are you that we can avoid catastrophic outcomes? Of course, using the jargon like what is your P doom? Yeah.
Yeah, I would say I am not very optimistic. I
Okay.
would say that,
Great to hear.
yeah, I would say I'm very concerned. Yeah, I don't know. I think it's a bit underdefined what P-Doom is as as is the trope, but if you made me give a number, I'd be like 80% or something.
Yeah. Wow.
Uh,
Yeah.
we got to get our stuff together as a society.
Has that changed since releasing AI 2027, or has it always been around 80%?
No, I think it's been pretty steady.
Yeah. Yeah. So I guess then looking forwards, um, what signals over the next 6 to 12 months, or if 6 to 12 months aren't enough time, um, do you think will sort of update that PDOM?
Yeah. So I guess there's like getting lucky um things that we could observe. Like,
Yeah.
for example, we could like randomly make an interpretability breakthrough
Yeah.
and suddenly start understanding how these models work.
Yeah.
If that happened, I'd become really, really optimistic. I'd be so happy.
Mhm.
Then there's also like government stuff. And I think government stuff is all more marginal.
Yeah.
But the government, could start enacting all of my favorite policies.
Yeah. Right.
And then I think things would also
Who
look way
knows?
better.
Yeah.
Yeah.
Yeah. So then for our listeners, what can they actually, I guess, do when it comes to those who find this argument compelling, where things are becoming really, really dangerous, and most likely, if things don't change and the status quo stays the same, things are going to be really bad. Are there any sort of concrete paths or actions that you would recommend taking to sort of contribute to this cause?
So the first thing I would recommend is just like, don't take my word for anything.
Mm.
Like try to think carefully about the situation yourself. Like
Yeah.
read my perspective, but also read many other people's perspectives.
Yeah.
And try to just like get an understanding of what's going on. And talk to people and read all the cutting edge stuff. And sort of just like think carefully about like what the situation looks like and what the best ways are for like you personally to make a difference. Some particular paths that I think are promising are things like working on various technical problems, like the alignment and control agendas that I mentioned earlier. Working in government. Government desperately needs more, I think, smart young people who understand AI well, which I think maybe many of your listeners are. And I think it could be very, very impactful to like be a congressional staffer or work in the White House or whatever, to sort of help them. I think like the Congress people, they really do need the young people to like explain how ChatGPT works to them. I think that looks great. I think public communications also looks good. I think it's pretty important that more people understand the general situation. And so I think things like, you guys having a podcast seems great to me. I'm excited about that. I'm excited. Yeah. So like, I don't know, like lots of things like that. I think there's tons of stuff to do. We need lots more people working on this issue. It's like, I think it's the most important issue in the world. And I think there are like hundreds of people working on it full time. And that's like pretty crazy.
Okay. Well, thank you so much, Thomas. This was a great discussion. I would really encourage our listeners to read AI 2027, read more of the work that Thomas does at the AI Futures Project, and then, read around in the space, counter arguments. We really only touched on the tip of the iceberg here, obviously, even within AI 2027. So we'll link to that paper, and there's a lot more exploring to be done. Hopefully this piqued your interest. But thank you so much, Thomas. The work you're doing is super important. And again, I hope this encouraged our listeners to think more about these things. So thanks for coming on.
Thanks, Owen and Will, for having me.